Hey, fellow problem solvers, Colfax Math here. I was going to do a short video on how to convert vectors from magnitude and direction into component form and back again in Google Sheets. So my first vector is vector A. It is 23 units long at 70 degrees. My vector B is 110 units long at 23 degrees. I create a column of magnitude, so I just put the 23 and the 110 there. I create a column up and down of angle, and I put the angles there. The horizontal component, I always start with the equal sign. It's going to be equal to the magnitude, so I'm going to click on that cell, times the asterisk above the 8, cosine of the angle. So I just start typing in cosine, that pops up. Sheets will only use radians, so you have to take your degrees and convert them to radians, and you do that by typing in radians. Radians will pop up, and we want to take the radian measure of that angle, and then I'll hit enter, and there it is. So the horizontal component of this vector is 7.87. On the vertical, I'm going to do the same thing. I start with the equal sign. This is going to be the sign. It does pick up, and then I'm going to start with the equal sign, magnitude, times, sine, be in radian mode, so I got to click on sine. I'll start typing in radians, type in radians of this angle, and I'll hit enter. And then there's my vertical component. Beauty of a spreadsheet is I can just drag this down right here. Now that I have my component form, finding 3a plus 2b is really easy. I could just find the horizontal component and the vertical component. So what I'm going to do right here is the answer to this is going to be equals 3 above the 8 asterisk, this plus 2, and I have to use the asterisk above the 8, 2 times that. That's going to give me my horizontal component. And right here, I'll do the same thing. And actually, I could probably just pull this over, and let's just double check that I did that correctly. This is 3 times that, plus, yep, that's all right. One thing I don't like to do is I don't want that many significant digits. I could turn that down right here a little bit, right, 2 significant digits. I also use this right here to center my values inside the cell. Right here, I'm going to do 5a minus 6b. So this is going to be equal to 5 times a minus 6 times e, enter, and that's going to be my horizontal component, and then I'll do that, drag it over here. That's how easy it is to do computations of vectors inside of a matrix. If I want to find the unit vector of A, I could just find the horizontal component. It's really going to be the same equation as this, right? Except I'm not going to take in, let me copy this, I'll place it right here. Except I'm not going to multiply by the magnitude. So I'm just going to delete that right there, hit enter, and then I'm going to take away the magnitude in the front of this. That's going to give me the unit vector magnitude in y. So there's a unit vector in the vertical. So what I'm saying is the unit vector of A, when it is exactly 1 unit, it will go 0.34 in the horizontal, 0.94 in the vertical. And I could check that pretty easily here by finding the magnitude of my unit vector. I'm going to set that equal to the square root. So I start typing that out. That pops up. The square root of this quantity to the power of 2. So that cell squared plus this cell, and this is a caret above the 6 squared, and I'll hit enter. And that equals 1, and that's why it's called a unit vector. So I could actually do the exact same thing here too. I could find the magnitude of that. Let's double check that it pulled up the right one. It did. And then I'm going to drag that one up here to convert my components back into magnitude and direction. Let me turn those significant digits down. And then now this could be a little tricky here. So what I got to do here is I got to find the angle between these 2 vectors. I'm going backwards. So I'm going to start with the equal sign. Remember, everything it does is going to be in radian mode. So I got to take my final answer and convert it to degrees. So I'm going to start typing in degrees. I'm going to do degrees of the inverse tangent or arctangent. So I type in arctan, maybe just arctan. There it is, inverse tangent of values in radians. And I want to do my opposite over the adjacent. So that's my y value divided by my x value, enter, and there it is as an angle, 33.7. I'm going to drag that down here, double check that makes sense, degrees, arctan of those two, and then I'll drag it down here too for the unit vector up above, and that kind of makes sense as well. Hopefully that made some sense doing vectors and matrices. These skills and understanding this is really kind of a big part of linear algebra, but I'm almost guaranteed that you're going to use some sort of matrix or spreadsheet in whatever career you pursue. So hopefully that helped. Thank you for watching. Any questions at all, please post them in the comments.